So we hear the SID Display Week, and who are you?
I'm John Kymissis. I'm a faculty member at Columbia University, and I'm also here helping out with the job fair for Lumiode. I'm a co-founder of the company.
So Lumiode, what does Lumiode do?
So Lumiode makes a micro LED display, which uses LED wafers and then adds the backplane to them, which allows for addressing higher luminance and higher efficiency than you can get using other techniques.
So you just take LED wafer, like one of those round things?
Yep, it's like a clear round thing, and then you add electronics to it and use that to make the display.
Is that how the micro LEDs are going to work?
Well, it's one approach to making micro LED displays. There are a few different ideas that are floating around. One of them is to take the LEDs. So LEDs are really bright. So if you think about a normal display, if you whip your phone out, it's maybe 500 nits. Some phones can reach a peak of maybe 1,000 nits. That's the unit of brightness. LEDs are about 50 million nits. So they're much, much brighter than anyone would need for a display that you're looking at directly. So one idea for micro LEDs is to take an LED, chop it up into little bits, and then spread them out. And that gives you the advantages of LEDs, but at a brightness, at a luminance that's useful for you. And that's what we call a chiplet kind of approach. The other way is to make very intense small displays, which can be useful for augmented reality. It can be used for some medical type devices, for example, where you might project imaging onto the body of something that's otherwise invisible, so that while you're doing a procedure, you can see what you're doing.
Projectors, maybe.
For projectors, pico projectors, stuff like that, headlights, etc. And that's what we call a monolithic micro LED. So there you make the whole thing into a chip, you add electronics, which allows you to do the addressing, and then you turn it on and you get that extremely high luminance and all the good efficiency advantages of the LEDs.
But isn't it possible to tune down the brightness? And
you can absolutely tune it down. It's just kind of a waste, right?
So you have this potential of going up to 50 million.
That's right. And so there's nothing to stop you, of course, from running them at a lower intensity, and that's certainly an option as well, and something you can take advantage of in a passive matrix, for example. But those applications today are reasonably well served by OLED. OLED microdisplays, like the one in the booth next to us, are pretty amazing, and those will deliver up to something like 6,000 nits, maybe even higher. And so for direct view, that's the competition, and we'll have to see what works the best.
So when you split up those LEDs, only in four, or in like many tiny small parts?
Oh, it's millions, yeah.
One LED goes into millions of small. It's kind of like
we start with a wafer. Yeah, it's almost like dust. The folks that do chiplets, it's pretty impressive because they'll take a wafer, which might be 100 millimeters in diameter, and then cut it into little pieces that are 100 microns on edge. So you wind up getting something like 1 million chiplets out of a wafer. And then you have to handle those, not 1 million, it's like hundreds of millions actually.
Yeah.
And then you spread those out and it works.
But don't you have to like plug them in the right way or something?
Yep, that's the kung fu that makes the chiplets, pays the bills for the chiplet people. So yeah.
Does it work?
Absolutely. There's some great demonstrations of that. I think... I don't know if they're exhibiting it, but Acceleprint was at the iZone last year, and they showed some really beautiful displays. And they use an elastomer-based process to sort and separate the chips, and then they wire them up. And there are a number of other companies working on this as well.
And so when you have all this dust of micro LEDs, then your technology goes in there to make it work, or?
No, so ours is a different approach. So the dust is there so that you spread out the LEDs. You get maybe a 1% surface coverage, maybe even less. And that gives you a reasonably good intensity, the long lifetime that you expect from LEDs, and some efficiency advantages over other approaches. Our technology, the micro display technology, makes sense when you want a high luminance, so when you want a high brightness. For example, something you might put into an augmented reality system where it's bright enough to overcome outdoor lighting, or where, again, you might use it in a projection type applications for augmented reality or other kind of more niche.
How do you make sure it doesn't get too bright and doesn't damage the eye?
So the damaging the eye, it's there are standards for how much light intensity is harmful, and a lot of it has to do with how focused the light is. And in visible light, fortunately, because of the blink reflex that you have, there are some limits. Now, LEDs get you within maybe an order of magnitude, maybe 1.5 orders of magnitude, the luminance of the sun if you drive them aggressively. And looking at the sun is harmful for a number of reasons. But there are standards that you can apply, which are inherited from the laser community, that can tell you how bright is too bright. And generally those are pretty high for visible light because of the reaction that people have.
So a couple days ago at the award night, you got the award.
I did.
So what did you get?
Oh, I was very honored to be chosen to be an SID Fellow.
So what does that mean?
So, that's actually a little bit of a complicated question. This is a good question. So, SID Fellows are chosen from amongst the membership of the society, and there are a few requirements. One is a certain level of service, and so I've served as an officer for some years, and also you can meet the service requirement by having a certain level of publication activity, and so that's the first part. You have to have been a member for a certain number of years, and then there's some selection based on your technical background. So it's supposed to be a selection of folks that are, participating in the society and that have, a strong track record of performance in the field of displays.
So you've been involved with the SID for a while?
Oh yeah, I think my first SID was in 20 years ago.
20 years ago.
When I was a student.
But that was, 20 years ago, it wasn't the micro LEDs, right?
Oh, no. I've worked on lots of other displays.
What did you do?
So I've worked on a lot of stuff. So I worked on liquid crystal displays. I've worked on field emission displays, which most people have never heard of.
What does it do, the field emission?
The field emission display was an idea to make a type of cathode ray tube that was flat and thin. And I worked on that for my PhD. And it was a lot of fun. I learned a lot. But
did it work?
Well, the thing that I did worked, but the whole field collapsed about 2 years or a year and a half before I graduated. So,
why?
Well, there was a startup called Candescent. Well, there are a number of reasons, but sort of the precipitating factor for at least the lack of interest on the U.S. side was that there was a lot of development and a lot of really great technical work at Motorola, Candescent, Sony was working on it, Canon, Toshiba, Futaba, there's tons of research on this. But it was a race against liquid crystal display, and Candescent declared bankruptcy after failing to secure a round of investment, and that led to a reevaluation in many companies, and so Motorola pulled out, and then after that it stopped being considered a viable option. Liquid crystal display had won the race. And
it's very hard to compete with LCD.
Yeah, it is. And 20 years ago,
Many have tried, right?
Well, LCD wasn't that great when people started working on field emission display. So field emission display started in the 70s when LCD was not considered a serious display technology. There were other options like plasma and also thin film EL, which no one's heard of. And so, there's lots of competition. And even today, LCD, it's pretty dominant. I wouldn't bet against it in the near future, but OLED is doing a great job. And there are lots of other technologies that are looking to overcome some of the shortcomings that are there.
And so after that, you did some other display stuff?
Yeah, so I worked. I was working in organic electronics as well, which is something I did for my master's thesis, and so I did a postdoc in organic electronics, which was great, and then basically continued working on that kind of stuff.
And organic electronics is, for example, what's in the OLED?
Yep, it's that family of materials. I didn't work on OLED specifically. I worked on photodetectors and organic field effect transistors. That's an area I've worked in a fair bit. And then after I moved to Columbia University, I also got involved in some research on recrystallized silicon, and Lumiode was born out of that activity.
So why do people want to work with the organic materials?
So organic materials,
what's good about it?
There are a number of benefits. One is that they can be processed at very low temperatures. So one of the things that we do in our group is we work on adding organic electronics to polymer piezoelectric materials, which do not have a very high temperature tolerance. And so we're able to add amplifiers and switches and other control structures without damaging the underlying material. Another advantage of organics is that they can be easily deposited on high-quality flexible substrates. They're also natively flexible themselves. That's useful for piezoelectrics because we need to develop significant strain for them to be useful, but they're also used for flexible displays. Some people have worked on stretchable displays using organics. And then they're also very friendly because of that low thermal budget for co-integration with other devices like OLEDs, photodetectors, photovoltaics, chemometric sensors, vapor sensors, lots of other stuff. So there's a lot of opportunity to make hybrid systems that develop new functionalities.
Do you think sometimes in the display industry, sometimes the cash is missing? Like there's some awesome ideas, but then nobody wants to invest $1 billion to make it real or something like that? Yeah? And is that a sad thing? I don't know if you're the money person.
I am totally not. I'm at a university, so I work for a nonprofit. So, Well, I will say displays in the U.S., that we don't have any serious national programs in displays anymore. The U.S. had a number of them. But, ideas with merit can be funded, and that's a mix of, government sources. There are also companies that still generously support some university research. And, I think, it's not like falling off a log, but ideas should have a little bit of friction to be implemented because that ensures a reasonable level of quality.
Because is it true that in Asia in the 90s or was it 2000s or something like that, then they decided to put a lot of money in displays, and that's why they kind of like dominating displays?
Yeah.
And the US or Europe didn't.
Maybe, but there are also, we could get into the economics, but there are other reasons that Asian countries are dominant. And there are reasons beyond investment which mean that manufacturing can be more efficient and more effective in those countries. And that also relates to the tax structure, the investment structure, things like that. In the U.S., companies need to have certain gross margins. Those demands are higher than they are in some other countries as well. And so, it's actually that's actually a pretty complicated question. But, if you look at Japan is a very high cost, and yet has a really outstanding display industry. So it's not just about cost. It's also about know-how, ability to do manufacturing, presence of the supply chain, coordination with the government. There's a lot going on.
So right here at Lumiode, you're at the student job fair. Are you recruiting?
Oh yeah, we're hiring. We have four openings, Vincent? How many openings are there?
Sorry?
How many openings are there right now?
We have 5 active openings
right now. 5 active openings? Okay. I wasn't sure if one got filled this morning.
So there's still more.
What are those openings?
So we have product marketing and 4 technical positions in process engineering, TFT simulation, packaging, and optical design. So lots of technical areas across the board.
Where are those openings going to be? So where are your headquarters?
We're in New York City. So those openings are in New York.
New York City, like...
in Manhattan.
Manhattan?
Yes.
There's like your office right there?
Yep, we have an office in Manhattan, and then we're soon going to be moving outside of Manhattan into the Bronx.
So do you want to hire the best candidate from anywhere in the world, or
Absolutely.
Where do you want them from?
We want the best candidates from anywhere in the world. So anybody that's looking to apply, Lumiode.com. It's pretty straightforward. All of our postings and things are listed directly on there.
And so if they join your company, they could be part of the future of AR projectors.
Yep.
Lots of cool stuff, right?
Yeah.
That's the promise. Yep.
Yeah.
Absolutely.